Okay. Good morning, students. We'll start with chapter 8 now. We have done volcanoes, and I gave you enough time to finish off with your written work with volcanoes. So we'll start with earthquakes now. I think most of us know what an earthquake is, and most of us would have experienced earthquake also once or twice in our lifetime. So a sudden trembling or a vibration in the earth's crust, we call it that as an earthquake, and it generally happens due to either external or internal forces. That means forces which are acting either inside the surface of the earth or outside the surface of the earth. Actually, the rocks are very hard and they generally do not break very easily, but when they break because of the compression which happens inside the surface of the earth, a lot of waves are generated which causes distortion and breakage inside the surface of the earth, and this movement is called an earthquake. And these waves are primarily of three types: the primary waves, the secondary waves, and the long waves. So the primary waves, which are also called as the P waves, these waves they move through solids, liquids, and gases. That means they can move through all the three mediums. Secondary waves, they travel only through solids and do not penetrate into the dense molten lava or the dense molten core. So they are able to travel only in the solids. And long waves, they generally are not traveling inside the surface of the earth, but they travel along the surface of the earth like sea waves, and their speed is very, very less, or they are very slow. Now, in your books on page 64, they have given you the very first page of your chapter earthquakes. They have given you some terms which are very, very important. One is the seismic waves, of course, the waves which are released due to powerful vibrations or tremors or shock waves, and they're called as seismic waves. We generally call them as earthquake waves. Then the seismic focus, the earthquake originates from inside the surface of the earth. So that point from where the earthquake originates inside is called as a seismic focus. And the point directly on the surface of the earth, vertically over that focus on the surface of the earth, is called as an epicenter. And the study of earthquakes on another earth vibrations is called as seismology, where it is recorded in an apparatus. It is called as a seismograph. And seismologists are the scientists who study the earthquakes, and the magnitude is the number related to the total energy released by an earthquake at that point of time. So all these terms are very, very important. They've also given you a diagram of the uh, instrument, the seismograph, which records all these movements. Though this is not in our syllabus, the working and all is not in our syllabus, you need not draw the diagram as well. Now, why are the earthquakes caused? The causes of an earthquake. There are main four causes of an earthquake. One is called as the volcanic activity. In the previous chapter, we studied about the volcanoes, and we saw that the magma with a lot of force is brought up on the surface of the earth. So when the magma is rising up in the pressure caused due to steam and gases, when it rises up or travels up, it causes a lot of movement inside the surface of the earth, and that can cause an vibration, and that vibration can lead to an earthquake. That is your first cause. Then the second cause is folding and faulting. So when this is basically an internal force, so it's the movement of the earth's crust horizontally or vertically inside the surface of the earth is called as folding and faulting, and this can cause an earthquake to occur. Then is the anthropogenic causes. Anthropogenic causes are basically causes which are basically by you and me, like when we do mining, blasting of rocks by dynamite to construct dams or bridges or nuclear explosions, and we make lakes and reservoirs behind the dams. A lot of water is put onto the earth's crust, and that pressure might cause the earth crust to break or shift, and that breaking and shifting will cause an earthquake. Then, of course, the fourth one is plate tectonics. We all know that the entire earth is made up of small and big plates, and these plates move against each other, move towards each other, they slide past each other, and when they do so, they cause a lot of tremor and vibration, thereby causing an earthquake. Now, we all know that earthquakes are very bad. Wherever they are caused, wherever they happen, a lot of destruction happens to life and property. So, humans, life, animals, loss of man made structures, railway tracks, factories, fires happen in factories because if the furnace is burning or if the fire is burning, an earthquake might cause that fire to spread. Then gas cylinders can burst. Landslides are caused due to instability or disturbance in the loose material on the mountain slope. So all these effects happen because of earthquake. Now sometimes what happens is dams can also break due to this vibration, leading to flash floods, because the reservoir which is behind the dam might break, the wall might, the embankment might break, and the entire water will flow downstream, causing a lot of floods. Then a landslide, whenever it happens, it can block the path of a river. And if the landslide blocks the path of the river, the area behind that will get flooded. And if the earthquake happens on sea floors or on coastal areas, it gives rise to very, very huge waves. And these huge waves can cause tsunamis. We all have heard about tsunamis happening in the Indian Ocean many a times. But everything is not bad. There are certain good things also which happen when an earthquake is caused. So those are called as your constructive effects. So when the earthquake is caused, some cracks, some fissures might open in the surface of the earth, which might give rise to geysers or hot springs. And then these geysers and hot springs can be used for geothermal energy. I'll be posting a link of a geyser video also here, so you can have a look at it. Then coasts, they get submerged, giving rise to bays and gulfs. Earthquakes are also found in the same zones where the volcanoes were found. If you remember, we did it the last time. The Circum-Pacific Belt, which is also called as the Ring of Fire, and the Mid-World Atlantic Belt. These two pictures I had sent it to you during the time when I had sent you the volcano chapter. So the same place wherever the volcanoes are found, maximum of the earthquakes are also happening at that same place. So that automatically tells you that wherever a volcano happens, it will or it might give rise to an earthquake. But the opposite might not be true. That means an earthquake might not give rise to a volcano, but a volcano 99% will give rise to an earthquake. And in India, the Himalayan region, being the fold mountain region, has maximum earthquakes. So we have this belt of the Himalayan belt, which moves around quite, because we all know that Himalayas are still growing and they are still pushing, that Indian plate is still pushing towards the Eurasian plate. And this movement is happening continuously, and because of this movement, a lot of earthquakes are caused in the Himalayan belt. Apart from that, we have one more in your book. If you look at, they've given you a knowledge booster on page 71 about the island of Haiti, which happened in 2010. So this is also a very strong earthquake which had happened at that point of time. And they've given you a lot of other earthquake data on page 72. You can just go through it, though this data need not be learned, but this just should be known for your general knowledge. So this is again a very, very small chapter. So I have finished it within a few minutes. And there's nothing much in this chapter to learn about, and therefore I have finished it in a single video. Please do watch this video and let me know if you have any doubts regarding the chapter. Bye bye.